has been a cold honor, I guess, with a stream and a valley named after me. But I have been working in Antarctica for about 30 years, and I started as a junior faculty member at MSU, and I still remember my first season in Antarctica, and I had read all the early explorers' accounts, and it was all doom and gloom. I don't know if you've read any of them, and there's a book out back about first exploration of the South Pole, but it was all doom and gloom and no life. They were portraying Antarctica as a dead continent, and as you'll see from this map of Antarctica back here, this is the way Antarctica is viewed today in any textbook. It's not part of the blue planet, it's white. And that bothered me. I come from a biological background, and I couldn't see this much real estate on our planet being dead. Okay? And Antarctica is twice the size of Australia. It's our 5th largest continent. It's the highest, driest, coldest continent we have on Earth. Okay? The South Pole is at 10,000 feet. East Antarctica, which is this part over here, it's about 13,000 feet in elevation. So it's quite high. It's cold. The average temperature is minus 50. Okay? I mean, so I feel right at home in Bozeman. It's minus 50. The coldest temperature recorded is a minus 130 Fahrenheit. Okay, and that's pretty tough. All right, so now you can see why the early explorers, many lost their lives, thought this. Okay, so one other thing is Antarctica is covered with ice. 99% of its ice averages almost 2 miles thick. 70% of our planet's fresh water is there. Okay, and if it melts, and it is melting, you'd be in denial if you didn't think so. That's another talk. Okay, it is melting, and when it melts, sea level is going to rise about 200 feet, and we'll have to have scuba gear to tour the Statue of Liberty. All right. Well, in the year 2000, I was at an international meeting in Tokyo, and we put together sort of a group of specialists to look for life and understand if there's liquid water on this continent once and for all. It took a long time to get to that point, but we got funding to put this group together, and I was lucky enough to chair it. So in this picture here, you'll see I published this in 2009. After a meeting in St. Petersburg, Russia, we sat down with an illustrator and came out with this current view of Antarctica, where we have lakes, all the little blue dots. There's over 200 lakes we believe are there. That Lake Vostok is 3,000 feet deep and the size of Lake Ontario, and it's under 2.5 miles of ice. Okay, see, this is one of the 5th largest lakes on our planet. We've never been there. There's also river systems that we believe rival the Amazon. That space there, that blue space that you can see, is about the size of the Amazon River Basin, and some of these river systems are the size of the Amazon. We haven't been there yet. Okay, I want to tell you a story of the first exploration of one of these systems about 2 months ago, done by a team I was chief scientist on, and I think we've changed the view of Antarctica. So I'm going to take you to this part of the continent and talk about a lake called Lake Willans. You'll see the little blue dots there and some rivers there. Okay, for over 10 years, we only guessed that they were there. Okay, and I'll take you to that spot. Well, how do we know or why do we think there are lakes there? Well, we joined up with NASA, and using satellite images, we could see flat spots all over the continent. And this is where the ice sheet floats over these lakes. Okay, so that was our first impression of lakes, so we could count them up. And we know there's some huge lakes out there. Now, I'm going to show you a little clip that also transforms the way we see this Antarctic continent. It's not just this big, stable block of ice. Let's see if we get our little movie. Okay, so this is going to show you a cutaway. And we also, using satellites, can see the surface of the ice going up and down by measuring the using satellite altimetry over time. And we can define rivers flowing underneath the ice sheet. Okay, so we have all this indirect evidence, and we have these beautiful river systems like we'd see coming out of the Rocky Mountains. And we can get an idea of depth. So we have all this background data, but we haven't been there yet. So I want to take you and tell you how we did it just a few months ago, okay? So we went out to this Lake Willans area, and the first thing in Antarctica is, boy, you got to get a lot of stuff out in the middle of nowhere. You think going out camping's hard. We camp big time, okay? This is the biggest camping expedition you've ever wanted to do. Well, we flew everything down and took icebreakers, most of our stuff, to McMurdo Station down here, okay, where we could get in with icebreakers and big aircraft. Then we had to get all of our stuff out 800 miles to the site over this lake. So we bought some tractors, all right? We bought a whole bunch of Caterpillar tractors, actually 14 of them. And we put everything on sleds. And this picture here, you can see a tractor, there's another tractor, there's another one, there's one pull. And we put a traverse together that was a mile long and took 2 weeks to get out to our field site. So we started here, and this is the route with its camps, and then it got up over here to our Willans site. Here's the South Pole, so we're getting close to the South Pole. What's interesting is our road out there followed Robert Falcon's trail to the South Pole, the one he actually died on the way back. So a little history in this. So we followed his track for a while, okay? So anyway, we get out there, and we're on site. I didn't go on the tractor, my students did, and I'm not going to sit on a tractor for 2.5, 3 weeks. So we went in with aircraft, and we took the first plane in, and we're talking about now 10 years of planning, and this first aircraft went in and landed at the skiway, and it got stuck, okay? That wasn't fun, and it took a lot of effort to get it off. You can see it plowing snow, and it got stuck because the ice and snow, actually snow in this case, was warmer than it had typically been. The continent is warming. So what we did, just like when you come out in the morning in Montana and have to dig your car out, we had to get out there and dig out the skis on this airplane, and the pilot's in there reversing thrust, going back and forth, trying to jimmy it out, okay? It was unstuck, and then put these rockets on the side, or 4 on each side, and after 5 attempts, it got off and had to stop at the South Pole for gas to make it back to McMurdo's. But we got in, okay? Which was, okay, just part of doing research in the Antarctic. So we built a small city out in the middle of the Antarctic ice sheet, and this is our field camp. I just want to point out a few things. Here's our skiway over here for the aircraft, our main camp, and here's our little living quarters. These are all tents. We all had our own little customized tent to sleep in. We spent 3 weeks working around the clock because we had to melt a hole. We have the science budget was $10.5 million for this project. Our drill was $3 million. We have a special drill that drilled down very quickly to the bottom, and we worked round the clock. Here's our drillers on the left and scientists on the right, actually collecting samples from the site. So we worked round the clock. Nobody slept. It was very exciting. And you probably, the previous slide, you probably would have noticed we were wearing Tyvek suits. Because part of our protocols for sampling these lakes, part of our international plan was to do it environmentally in a clean sense, okay? So we had to show stewardship. So we dressed and went in between our little field tents, dressed up like this. This is walking between sites in a storm. And we did this to keep the environment clean and to keep our samples clean, because great claims need a great evidence behind it, all right? So this is how we worked out there for 3 weeks. And I did personally myself, I did 2 23-hour shifts, almost back to back. It was a lot of work for an old guy like me. Anyway, so this is how we did it. I'm just showing you a picture going down the borehole. We're almost a half a mile deep here. And these little whiskers here are helping us tell how wide the borehole is, so we know our tools can go down. And there's the bottom. And there was a lake there. Whew. Okay? It took a long time. It was 30 years of ideas, thinking this isn't a dead place. Okay? Over 12 years of deliberations suggesting there are lakes there and rivers, and there it is. There's the bottom. Okay? This is 28 January 2012, not very long ago. Okay? And this is the first picture about 2 days later of organisms under there. Whew. Okay? There's life under there, and some of my students are out here, and they took these pictures. Okay, I had a lot of grad students from MSU. 7 MSU colleagues were down on the ice with me. So now there's life down there. This is the first glimpse of life. And the DNA samples are coming back. They should be arriving this week, and we'll be able to sequence and tell you who they are. All right, so we got a lot of publicity, maybe not in Bozeman, but internationally. These are 2 New York Times articles, and in the short period between 14 January and 6 February, we transformed the way Antarctica is viewed. Okay, so 30 years ago we had a vision that it can't be dead, and now we showed it in this short time. So now the Antarctic continent shouldn't be shown as this white block at the bottom of our Earth, of our planet. It's part of the blue planet itself. There's living ecosystems that play a role in climate change, etc. Okay, well, where do we go from here? Okay, I'm very involved with NASA, and we have now defined in studies, there's 6 moons out here. This is Earth in the middle, and they have oceans under ice as well. Okay, as a matter of fact, there's 10 times more water in the outer solar system than there is on Earth. Okay? That's habitable space. Those oceans have been around since the beginning of our solar system. There should be life there. There must be. It would be in denial to think there wasn't. Okay, and we've started publishing now, and I'm focusing on Europa, putting a mission together. Right now, we're at about $1 billion. It's going to take to put a lander and drill through that ocean, or to drill through the ice into the ocean and find out where we are. So we not only have to think out of the box, but we have to get out of the box to make discovery. Thank you.